next up, we have Who Watches the Watcher, and it's moderated by Anewbiz. And if we are discussing the parenting of AI, then Anewbiz is the father of this conference. He's pulled it all together. So Anewbiz, please come up and welcome on your panel and talk about Who Watches the Watcher. Thank you.
Check, check. All right, thanks everybody for coming. I'm excited to dive into this panel. Bring my speakers on up to the stage, please. I am Anewbiz, the CMO of Secret Network Foundation. I'm going to be moderating this panel. I think it's going to be a great conversation. We're going to dive into who watches the watcher, understanding privacy and power in artificial intelligence. I'm going to go ahead and pass it just around, let all of the speakers go ahead and introduce themselves.
Sure. Hey, everyone. My name is Marek. It's really good to be back in Toronto, even though I live in San Francisco. I'm a U of T alumni. Any U of T folks in the audience? No? Wow, okay. So much for pandering to the audience. Yeah, so I work on Cella. I'm one of the co-founders of Cella, which is an EVM-compatible L2. Recently, we started Self Protocol. Self Protocol is a zero-knowledge, privacy-preserving, decentralized identity protocol. Who here has a passport? Anybody have a passport? Nobody has a passport. Okay, a few people are raising their hands. Amazing. So passports nowadays have these NFC chips on them. They're called biometric passports. And in there, your biometric data is signed cryptographically with a certificate of authority chain. And so Self Protocol basically verifies that certificate of authority chain in zero knowledge so that you can prove on-chain that you have a valid passport, and better yet, so that you can disclose information about yourself in a privacy-preserving way with third-party dApps that you might want to interact with. So think of it as a really cool new mechanism that allows you to prove that you're a unique individual, that you're a human, that you're not an AI agent, in a way that's very privacy-preserving, very relevant in this new agentic era that we're in right now. So yeah, that's me.
Hey everyone, I'll help Marek out. My co-founder went to U of T, so at least we have another person. So anyways, I'm Michael, co-founder and CEO of cLabs. Quick background on myself, I started at Microsoft, SAP Labs, and then also worked at Bain & Company and Bridgewater Associates. And before Zero-G started a Web2 unicorn called Garten that came out of Y Combinator. And now, Zero-G, what we're building is the largest AI layer 1 ecosystem. And as part of that, we have a decentralized storage network. We've got a compute network that does inference and fine-tuning in a privacy-preserving way using TEs, and we can definitely get into that. And then we have a layer 1 that's essentially infinitely scalable, both on the data throughput and on the transactional level, so that you can really, literally build anything on chain. So anything that's possible in Web 2, including many AI applications, you can now build fully on chain with our infrastructure.
Hello, and this is Chao, and I'm the co-founder and also CEO of Copus. So I'm an artist, and do you have any artists here creating, no matter what you like? Oh, yeah, we do have a few. And we're a content creation platform, and we're also making a content discovery engine, which based on what you're viewing, it will recommend you more related content no matter where you're at. So just like you may also like section, but anywhere you can visit. And yes, we use Zero-G as our storage for our content, so that's where we're here.
Awesome. Hi, everyone. I'm Sebastian, CEO at Ember Ai. We are infrastructure for execution focused on DeFi agents. I guess to plug maybe this, we'll be releasing a framework to build agents that do things in DeFi, automate strategies of all kinds. The Arbitrum Vibe Kit, so it's meant to be a vibe coding experience only, so you have your own trading strategies you want to just automate for you. Just keep an eye on social media for that.
Awesome, awesome. A lot of really good projects here. And at Secret Network, we build decentralized confidential computing infrastructure for Web3 and AI. And what we're currently launching is the Secret AI platform, allowing users to basically own their own data in centralized AI platforms such as ChatGPT. All the data, when you use ChatGPT, OpenAI sucks up all that data, uses it for their own means and to train their models. We believe that users should own that data and at least be paid for it if they want to let someone else use it. So on that note, we're obviously very focused on privacy. This panel and this event is very focused on privacy. So I wanted to just ask each one of you, how does your projects focus on privacy? How do you approach privacy with your own platforms?
Yeah, great question. So I think, yeah, so self, by the way, it's self.xyz. If anybody wants to check it out, it's a really nice, short, memorable domain name. We use ZK snarks to ensure privacy. And you know, it's funny because a lot of people talk about ZK projects these days, and really what they mean is the kind of snark part of ZK snarks, right? The succinct part. If you look at ZK EVMs, they're not actually offering typically any privacy. But for us, we're actually using you know, the ZK part, so the zero knowledge part of ZK snarks. So if you're not familiar with that, that's a lot of very advanced math and cryptography. Some people call it moon math, and it's pretty incredible. But with this moon math, you can effectively prove statements without revealing the inputs to those statements. And so you can prove, for example, using self, that you are not on the OFAC list, or that you are, you know, not that you are an actual human with a passport, without revealing, you know, the information on your passport. I mean, the OFAC one is pretty interesting. Like, where you don't have to reveal your name, your birthday, which country you're from, but yet you can prove that you're not on this, you know, U.S. sanctions list that you know, many banks, for example, enforce to, you know, prevent kind of money laundering and all of that. And so it's really, really interesting. I think the age is another really interesting one. You can prove that you're over 18, or I guess in Ontario over 19, without revealing your actual age. And again, we can do that with this advanced cryptography, which is just really, really cool to see.
That's really powerful. I've always wondered why it is that every time we go to a store and we want to buy alcohol or whatever, why we have to show the cashier exactly where we live, where we sleep. You know, it just it's always bugged me. So, but on that same note, what's really cool about what you're building there is proof of humanity in the age of AI. I think that's going to become more and more relevant and very important. So,
yeah, absolutely.
All right, and Michael, go ahead.
Yeah, for us, the way we think about privacy is because we have different layers to our infrastructure, different aspects of privacy matter at these different layers. So for example, on the layer one, it would be, can you do private transactions? So we haven't implemented that, but that's something that we're looking at in the future. What we have is on the, for example, storage layer, you could easily encrypt your data, and that allows a sense of privacy. And technically, we're also agnostic to what kind of privacy methodology you want to use. So if in the future, FHE becomes compute intensive enough, then you can definitely use that from a storage perspective as well. So we don't necessarily want to prescribe what the privacy methodology is, but really enable it through our infrastructure. On the compute side, that's where it gets kind of interesting, because different approaches have actually been tried. So ZKML, SPML, TEML, FHEML are all different ways of approaching inference and other type of compute applications through a privacy lens. But the issue that we found is that none of them are really production ready for consumer use cases, besides TEML. Because the overhead that you have between TE and kind of regular, let's say, inference that's not verifiable, not private, is almost zero. And so you could use it in the same way as if you would, ChatGPT, but with an open source model running in an TEML, which stands for Trusted Execution Environment, on an H100 NVIDIA card. And so that's why we've chosen to support that at the moment, but we definitely can also support ZKML and FHEML and all these other verification methodologies. It's just that if you wait an hour for a token to appear, that's not a great user experience. So for certain use cases that makes sense, but they're very, very limited. And so we primarily use TEs. The way TEs work, it's a hardware-based methodology, so there is actually an environment on that graphics card that's completely private. So you can run computations in that environment and then verify that something happened in that environment without outsiders knowing about it. And so it's quite powerful, it works very well, but there's a downside to it as well. You have to trust the hardware manufacturer. If the hardware manufacturer for some reason builds in a backdoor for a government entity, you don't necessarily know about it. And so it may not be the end solution, but it's the most practical solution at the moment that we've chosen to support just from a way of kind of working with these systems, but definitely want to support other methodologies in the future.
I love that answer. It's at Secret Network, we also use TEEs, and for much the same reason. There's other very powerful encryption technologies for confidential computing, and each one has its own place. For example, ZK is very good for something like an ID verification, but for AI inference, it's just not going to work. Something like a TEE, which has a faster and more efficient throughput, is what's needed.
Yeah. There are people working on that. It's going to happen.
Oh, I think so. There is people doing some very good work.
Yeah, he was saying people are working on it, it will happen. And I would agree there's some use cases where if it's a very small parameter model, it works okay, especially on like edge devices where you can use some type of ZKML methodology. But for larger scale models, even like 7 billion parameters, it already starts breaking down because it's a lot of latency you're introducing with the methodology.
I've always figured that the future is going to be multi-technology, not just multi-chain. And so a mixture of a TEE with ZK, FHE, and one of my favorites is actually MPC and TEE as a combination. By combining the two or more, you get very powerful use cases. Oh, were you going to say something? It's dead. I'll pass it. Did you want to? All right, and Chao, same question. How does your project approach privacy?
Well, so like one great thing about Web3 is they can keep you off from the authority. And recently you have found like a very interesting product market fit is the fanfiction writers in China. Because there are lots of fanfiction websites that have been taken down, and the police even go to invite those writers for some tea party. And what we do is like we allow the wallet only login. So first, like nobody will know like who writes those fanfictions and keep you safe from the biggest authority. And another thing is like we support crypto transactions. And these are all like Web2 writers, but right now they are learning to log in with their wallets and also to earn with their wallets. So it's a safer way to them, for them to, no matter where they live, basically. And the second thing is how we protect content creators, right? You don't want your own content to be pirated or learned by the AI very easily. So what we do is we have like a maze. If we detect there's an AI agent trying to visit our creators page, like trying to scrap out some content, we'll just generate random content for them. So if the creator is actually writing about a Harry Potter's fan fiction, it might just generate them like a Amazon River ecology study, just totally random nonsense. And good luck with those AI agents. Yeah, that's what the two main things we do to protect the privacy for our users.
I think everyone that's working closer to the end user and kind of on the application layer ends up with this temptation to, in AI, make very simple user experiences that require a lot of data and kind of a lot of personal information from people. It's really important when you're thinking about how to build these systems to try to separate those two things And within reason, right, obviously people are looking for that automation, but there are ways to let them own that information, right? For us specifically, I mean, we're dealing with DeFi execution. It's all about, you know, owning your own strategies. We do take a lot of data points that can give you good suggestions, help you, you know, explore the world in a more curated manner. But the key of this conversation, I think, lies around making sure that the data that you are using is not leaving the user's possession, right? Maybe you get permissions to access it. Maybe your system's built out in a way that you'd never need to touch it. So, you know, for us, distributing this as an open framework and letting people build out whatever strategies they want on their own computers, owning their own code, is, I don't know, kind of the best of both worlds in a way.
Awesome, awesome. So one of the things to really consider in the AI space and privacy, in centralized AI systems, you know who to go after. If there's a large data leak that exposes a bunch of sensitive information, you know that you can go after OpenAI. You know who's responsible. Now, in decentralized AI, it's a bit different because you don't know who's hosting the servers. You don't know who owns the hardware. So my next question is really double-clicking into that. In your opinion, who should be responsible for setting privacy standards in decentralized AI?
Yeah, it's an interesting question. I mean, I think ultimately it's going to have to be initially the decentralized projects, right? I think initially this will be too complicated for regulators to step in, and I think if regulators do it immediately, I think they may also struggle a little bit to understand all the nuances. But if the projects themselves, if the open source community doesn't do it quickly, then certainly bad things could happen, and then we might see an overreaction from regulators, and so in a way that could be even worse. And so I think it's certainly going to be the people in this room, the people working on these systems. I think we have to be as thoughtful and careful as possible. I mean, this is a crazy transition that we're going through. I mean, it's really hard to even predict what's going to happen in the next 5 to 10 years. If AGI really happens, everything about our lives may change just overnight. And I have a lot of conviction that decentralized systems are going to be the ones that are going to be preventing concentrations of power, ensuring that people's data remains private. I mean, just think about how much data you share with ChatGPT these days. It's crazy. I mean, the amount of information that they know about you. There's a lot of risk there, and so yeah, I think it's going to be it's going to fall on all of us.
Absolutely. At Secret Network, we're building the infrastructure, so we always come at that infrastructure level. And to be honest, part of that is because it's just a need. So many people building in the space aren't even thinking about the word privacy. So if we can make it easy for anybody to go ahead and just plug in, build the same way they would build anything, but add that privacy, that's the best case in my opinion.
Yeah, maybe just a quick follow-up. The topic of world came up in the panel before, and there was a lot of concern about people sharing their iris information. That's a type of data that I think a lot of people have concerns about sharing, and it's really important in this future where we're going to be thinking about how do we give UBIs, how do we differentiate between humans and agents. Right? I think this is the reason why World is solving it in this way. And I think one thing that's really nice about Self is that it solves it in a way that doesn't require you to share your iris information, right? You already have a biometric passport, EU IDs, Aadhaar systems. There's a lot of ID systems that have these cryptographic primitives that we can then bring on chain in privacy-preserving ways. And we think that that's going to be a really, really great way to protect users' data as we kind of go through this crazy transition that's coming about.
Yeah, so just our own spin on kind of the question, who's to blame if something happens at OpenAI? You have a centralized authority, and you could then extend that analogy and say, well, in a decentralized way, you have the protocol, so shouldn't the protocol be to blame? But that's kind of like saying the individual actors that are trying to attack the protocol are then the ones that should be responsible, but the protocol itself is to blame. So the analogy doesn't fully extend in that way. What the protocol can be responsible for, though, is to put in safeguards. So, for example, we have something called AI alignment nodes that we're currently researching, and in the future, we want them to basically figure things out like model drift, negative behavior by AI agents, kind of data poisoning attacks, those types of things that really influence the functioning of the protocol. So we definitely want to be responsible for that. But we can't possibly predict all attack vectors, and so there will be protocol upgrades over time. But it's really kind of nefarious actors that will try to attack the network in one way or another. And so the best that we can do is to ensure that there is slashing or economic incentive conditions so that these types of situations don't occur in the first place. And there's probably a finite set of things that can be attack vectors that we can think through, and then through experience, keep upgrading the protocol over time. So that's something that we can take responsibility for, sure.
I totally agree. And if it's hard to go after the sellers, it's probably like a little bit more easy to go after the buyers. And I think as a content creator background, they need better regulations for about like how AI, no matter if it's decentralized or centralized AI, to steal, kind of steal or learn from people's content, because every law, including the IP law, works very differently from every country, and your content might be safe by law in one area, doesn't mean that your content is safe everywhere. So we do need like regulations, and also decentralized storage providers, which basically do less KYC to their users. So they just know that even though they know the content, they don't know where it come from. It's still better for users. That's what we can do for best for right now.
Just to jump in real quick, because I think we're short in time. I want to talk about the government approach to this. It's definitely not the most popular take in Web3 especially, but there is a responsibility to, give a high-level guideline that will potentially be broken by private businesses, but that exploration needs to be held back, in my opinion, to some degree by the government, right? I don't think we can trust private interests to 100% put individual, best benefit in the first.
Awesome. Yeah, I think one of the big things that we all really should think about is how we can improve the education in the space on these issues. We are out of time, but I want to just thank each and every one of you for coming up here and for sharing. It's been a great panel.
Thanks, everyone.
Thank you.
Thank you.